You guys did great on stuff. I mean, I speak in terms of averages because I have to. Because I have to look at you can't look at the individual ones. The one question that seemed to throw maybe a third of people was there's one question on the project that said interpret the previous probability. What does it mean? What does it mean? And the only meaning to a 25% chance or a 70% chance or a 90% chance or a 99% chance or a 5% chance, the only meaning to that, like if you ask somebody, what is the chance you flip heads on a coin? 50%. What does that mean?
You gotta have a chance of getting like heads.
What does that mean?
1 out of 10 chance.
What does that mean? I love that. I love what you're saying. But the thing is that what does that mean? Like, yes, I agree that it's 50-50 or 1/2 or 0.5 or however you want to say it. Totally fine. I go with 0.5 myself, it's just me. But what does it mean?
Out of 100 trials, you get 50 heads.
On average, you're going to get 50. That's what it means. On average, you have to have somehow in the response, you have to nod to the idea of repeated trials. Because that's the only thing it means. If you hand somebody a coin and tell them it's 50% chance, what that means is, over time, that coin has produced heads 50% of the time it's been flipped. That's all it means. That's the only thing you can say about it, really, is over time, that coin has produced heads 50% of the time, and it produced tails 50% of the time. When you roll a single die, it produces sixes 1/6 at a time, or roughly 17% of the time. When you pull a card out of a deck, it produces diamonds 25% of the time on average. The on average isn't as important, although it's important. The over time bit is really what I'm after. If you really want to make me smile, say them both. On average over time. That really makes me happy. Because that's what it means. That's what it means. I started 105 this term again with the prisoner problem. Arrange the marbles so that you have a maximum chance of living. And what is that chance of living? And they say, well, it's a 75% chance of living right now. I'm like, sweet. So you're the prisoner standing in front of the executioner. You have a 75% chance of living. How do you feel? Well, the idea is you're going to live or you're going to die. There's two outcomes, yeah? There's two outcomes. You're going to live or you're going to die. But there's a 75% chance of living. So the way to think about that is if you put 100 such prisoners in a row, you know on average 75% of them are going to walk away alive and 25% are going to die. It still might make you queasy because you might be one of the 25, but you're 3 times as likely to live as you are to die in that scenario, yes? That's the meaning of probability. That's why I said you might want to look back to the box that's called the meaning of probability. Just because nobody ever explained that to me when I was studying the course myself the first couple times. We just talked about probabilities, we multiplied them, we added them, kind of like you were doing in the project, but nobody stopped to say, what does it mean? What does it mean to have a 1/2 chance, or an 8/9 chance, or a 90% chance? What does it actually imply? What does that tell you? What does it mean when 20% of pregnancies end in induction, in an induced labor? What does it mean?
So on average, you say
20%.
20% of women won't have that.
Yes, on average, over time, 20% of pregnancies are going to end. So out of every 5, 1. On average. That does not mean you know 4 people that got induced and you're the 5th one. That means you're going to get induced. It doesn't promise you that. It doesn't promise you no, 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 yes. No, 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 yes. Just like flipping a coin doesn't promise you heads, tails, heads, tails, heads, tails, heads, tails, heads, tails. It promises you 50% over time heads and over time tails. It doesn't guarantee you the order the stuff comes in. We said that quite a bit in 105, probably ad nauseum in 105 actually, I think about it. Probably to the point like, okay, we talk about something else now. But it's huge because it's anti-human. We don't think like that as human beings. So that was the only question I think that threw people. And it wasn't like the majority. It was just, I would say, it was like a 2-point problem, not the end of the world either. So it was the only one that kind of threw people. But I talk about that constantly in this class, the meaning of what probabilities mean. What can you take away from them? And we're not quite into the theoretical study of probability just yet. I want to come back to that for sure. But other than that, everything looked good. Everything looked good. You guys have any questions for me? I'll get the stuff back to you maybe towards the break. Kelly, yeah?
Yeah. I remember in 105, it's like, how do you know when you've reached enough time?
Good!
But, and then I was thinking about that just now, instead of listening.
But I love what you were thinking about it. Go ahead.
Well, because you have to divide your options up.
Yes.
And then that's the number you have to get. Until you get that, then you know you've got enough time.
So what Kelly just asked is a fantastic, it's actually a 244-ish question. She said, how much time has to pass until you can make a reasonable estimate as to what's actually going on? So I answered that question on the first day at 244. I give everybody a penny. And I say, here's a penny, spin it, and let the penny fall to earth under its own power. Don't flip it and catch it and put it on your hand. Because that's 50-50. By definition it is, because there's two outcomes and you're stopping it and putting it on your hand at a random spot. So it's 1/2 because there's two equally likely outcomes. What happens when you spin it? And the question is, the more you spin, the better the estimate that you get is. The better the estimate that you arrive at gets. You get better precision the more you spin. So the technical answer is you have to theoretically spin an infinite number of times to get absolutely zero precision loss. But you can deal with far fewer than infinite trials to get relatively decent precision. You are getting into 244 with the question. It's part of what we're talking about today with the idea of variation around a sample, but it takes about 10 weeks to develop all the tools necessary for that to answer that question. That's okay. You're well on the way today. But there's not a number I can give you that says go do this, because it depends from trial to trial. The mechanics don't vary, but the number can vary depending on what you're estimating. If you have 6 sides on a coin, or if you have 10, Max is in the game of life right now. He always wants to play life. And it's cool because there's tons of mathematics and probability involved in the game of life. Actually, any board game. Any board game that requires a spinner or a set of dice is loaded with probabilities. And he's figured out he likes to play life because it has the spinner from 1 to 10. But depending on your career, you get certain money paid to you by the bank and by players depending on what number is spun. And he gets, was it last night, 3 nights ago or something, he was playing, his number was 1. And 1 hadn't come up in like 20 spins or something. He's like, this sucks. What's the matter? He's like, they haven't gotten 1 yet. I'm like, holy crap, he has an intuitive gut feeling for the fact that there should have been a 1 by now. Like, that's awesome. My poor kid, I polluted him. But it's like, it is an intuition, but if you need more precision than intuition, we'll develop those tools as we go. If that's okay.
No.
It's not okay. There's a very good, I can give you the formula right now if you want it. I don't know if you want it right now. I mean, there's definitely a formula that's not going to make squat sense to you, but there is a formula that depends on the situation, depends on the number of variables, but you can generate how many you need to do until you get to where you need to be. But there's always going to be a measure of offness based on that. A coin flip, there are 3 givens, and we hit them all in 105. Decks of cards, poker deck of cards, flipping coins, and rolling dice. Those are the 3 gimmies, because those are the most common in our worlds. But as soon as you get away from them, you can no longer talk about, or I should say, we didn't talk about this, but the game of life, the 10 spot spinner, okay, equally guaranteed. Most things in life, though, don't have a die that you can roll. So, for example, if you want to measure, attention span deficit of ADHD children who go off their meds for 3 or more weeks, you can't like roll a die and be like, let's see what happens today. You have to watch the kid. The kid is the die. But the guy doesn't have a shape that you can analyze. You have to analyze his behavior or her behavior to see that. So the dice analogy is a good one, although it's a little bit limited. That's why I like what we're studying in this class, is we're getting at the life dice, if you will. Good question. I love the fact that you just zoned off and thought about that, Kelly. It's fantastic. I mean, you're telling us why we're here at the end of the day. How many of you guys take a 244? Oh my goodness, only a handful of you. That's okay. I'll convince more of you by the end. Don't worry. I'll beat you into that class and make you take it. It really is a logical place to go from 243 because of that question. So, other questions? My God, the water in this town. I swear to God, I'm from Delaware. Arguably the worst water in the country. Arguably the worst water in the country. And every day I get to wake up. After 10 years, I get to drink that. It's just ridiculous. It's ridiculous. I'm talking about bad water in bed. I'm like, what are you talking about? It's like a cesspool where it comes from. You can't imagine the damage of some 30 years of drinking Delaware water, 30 cumulative years of damage, like in this fountain of youth anatomy or something. No questions? We're okay so far? Maybe you'll think of them as we go. I hope so. I hope so. I hope so. So where were we last time? Thank you guys very much for letting us have the class time on Thursday for the math contest. It was a ridiculous success. I just got another email from another math teacher from around the state whose kids came. We got 13 schools to come out. Sisters, Bend, Burns, Summit, Mountain View. Paisley won first place in the lower division. Paisley, I was freaking stoked. A little school has never won first place in this competition, and we've done it for like 40 years. And it's always either Bend, Mountain View, or Summit that win first place in upper and lower division. This was the first year Paisley took first place lower division. That was
Was there just one student?
no, it was 9, which I think is all the students at the school came. All 9 of them came, and they were totally amped up and jacked up. It was wonderful. We took a picture with them afterwards, and they were all gathered around us. I'm like, you know, my favorite color is, right? They're like, no, what? I was like, duh, Paisley. They were like, oh, I'll see you next year. They went running out. I'm like, oh my God. They were stoked from 8 o'clock till 4 o'clock. I've never seen anything, well, besides myself, never seen anything like it. So, totally rad. So thank you for the time. I appreciate you donating that class time on Thursday. Hopefully you didn't mind. I'm guessing you didn't. All right, so what we were looking at last